Let's unpack this. We are diving deep into a system that is, well, it's supposed to be the operational heart of justice, but it often feels like the most chaotic part. I'm talking about courtroom scheduling, the actual nuts and bolts, allocating time slots, judges, courtrooms. When it's done poorly, it's not just an administrative headache. It causes the whole system to grind to a halt.
It does.
You get these massive backlogs, delays that can stretch for years, and, that really erodes public trust.
Absolutely.
But what's happening right now is this really revolutionary pivot. Artificial intelligence, and specifically a technique called reinforcement learning, is stepping in to solve what has always been like a logistical nightmare.
And that's really the mission of this deep dive.
Yeah.
Because when you look at courtroom scheduling, you realize pretty quickly it's not just, managing a calendar. It is one of the most complex constraint problems you can imagine.
So many variables.
So many. You're balancing strict case priorities, the different availability of judges, the physical courtrooms, attorneys who have to travel, and then this thick rule book of local procedures on top of it all. A human mind just struggles with that scale.
It's impossible.
It is. So the goal for this tech isn't just about making things faster. It's about finding truly optimized solutions that maximize efficiency, yes, but also fairness and maintain the integrity of the courts.
So why has this always been such a monumental challenge? Let's get into the specifics. What are the difficulties of doing this manually? We've kind of distilled it down to 4 core pain points. The first one is the most basic, but it's also the most persistent. It's just conflicts and overlaps.
Bill booking problem.
Exactly. You obviously can't schedule a judge in 2 courtrooms 50 miles apart at the same time. But the real problem isn't that initial mistake. It's the lack of dynamic adaptation.
Right. What happens when things change?
Yes. Because traditional static scheduling just falls apart the moment reality hits. A plea deal falls through, a witness calls in sick, an emergency motion gets filed. That one single change, that one domino, can throw an entire week of trials into chaos.
And it causes this huge ripple effect.
A huge ripple effect.
Right.
We're talking widespread, cascading delays that push back hundreds of other cases. And, we all know the saying, justice delayed is justice denied.
For sure.
Our second challenge is all about logistics and the massive cost, both financial and human, travel and resource allocation.
The geography problem.
Exactly. Judges, attorneys, they often have to circulate within a huge jurisdiction covering multiple courthouses. And when the scheduling is inefficient, you literally see judges driving hundreds of unnecessary miles every week.
Just wasted time.
Completely wasted time. Think about the hours they lose sitting in traffic, hours that should be spent on the bench or reviewing filings. It causes these huge operational delays, and the costs just skyrocket.
And that mismanagement of resources, that directly feeds into our third big challenge, doesn't it? The backlogs.
The dreaded backlogs.
Persistent judge backlogs. We aren't just talking about a pile of paper on someone's desk. We're talking about thousands of pending cases where real people are just waiting for their day in court.
And the manual systems are they're overwhelmed.
They're totally overwhelmed.
Yeah.
It's almost impossible for a person to efficiently manage this pileup while also factoring in all the other constraints. You have court holidays, mandatory training, vacation, rest periods to prevent burnout.
So the cases just stack up.
They just stack up. And what happens then is you start prioritizing only the most urgent criminal cases, which means, equally important civil or family law cases get pushed down the road again and again.
Right. And finally, what makes this whole thing uniquely difficult, say, compared to just optimizing a factory floor, is the fourth challenge.
Yeah.
Just the sheer volume of hyper-specific local rules and regulations.
Oh, yeah. This is the big one.
It's not a national system with one playbook. Every single jurisdiction, sometimes every individual court, has its own rules. They govern everything from court hours to which case types get priority.
And if you're using some traditional software, trying to adapt to those local rules requires constant human oversight. It's expensive, and frankly, it leads to a lot of errors.
Yeah.
The level of flexibility you need is just staggering.
Here's where it gets really interesting, because the solution we're talking about is almost tailor-made for this exact kind of dynamic complexity, reinforcement learning, or RL. So for anyone who isn't familiar, RL is a type of machine learning where, we don't just feed an algorithm data, we create an intelligent agent that learns by doing, by interacting with its environment. Think of it like a logistical genius playing a super complex video game.
That's a great analogy.
The agent makes a decision, an action, and then it sees what happens. If it was a good move, it gets a reward. bad move, it gets a penalty. And through millions of these trials, it develops a policy, a really sophisticated strategy, to get the most rewards over time.
Exactly. So in our courtroom context, the RL algorithm is trained to allocate all those resources, judges, courtrooms, time slots.
Yeah.
It learns what a good schedule looks like, not by being told every single rule, but by being rewarded for outcomes that, minimize conflicts, reduce backlogs, save travel time, and satisfy all those local rules at the same time.
To really get how powerful this is, we should probably break down those 4 key components of the RL system as they apply here.
Yeah, that's a good idea. So first you have the states. The state is basically the current situation of the entire system. And it's massive. It includes every judge's assignment, their location, their available hours, the status of every single pending case, courtroom availability, and the exact travel time between every possible location.
So it's not just recognizing a judge is free. It's knowing that Judge A is free, and she's only 10 minutes from courtroom B, and she has 3 felony cases waiting, and she's required to take a lunch break at noon. All of that is the state.
All of it, which leads to the actions. These are the decisions the agent can make. So an action might be assign Judge A to case X in courtroom B at 9 a.m. or reschedule hearing Y for next Tuesday. The agent explores millions of these possible sequences of actions.
Okay, and now we get to the heart of it, right? The rewards. This is the incentive structure. This is where the humans tell the AI what actually matters.
Precisely. The agent gets big rewards for outcomes that solve the problems we just talked about.
Yeah.
0 conflicts, minimum travel, maximum number of cases cleared.
But you have to weight those rewards, right?
That's the crucial part. This is where the nuance is minimizing the backlog worth 10 times more than minimizing travel? Is avoiding a double booking worth 1,000 times more? The AI learns the optimal schedule by managing these complex trade-offs, all guided by that weighted reward function that the court administrators design.
And that's what stops it from just optimizing for speed at the expense of, say, fairness or making sure judges don't get burned out.
Exactly. And all of that learning, all that trial and error, it converges into the final piece, which is the policy. The policy is just the overall optimized strategy. It's the set of rules the agent now follows to make the best decisions going forward.
So let's connect this all back. Let's talk about how RL in action actually solves those 4 big challenges we started with, because the gains seem immediate.
They are.
Okay, take cutting ethics. The dynamic adaptation. The RL system isn't just setting a schedule and walking away. It's constantly monitoring the live environment.
They're always on.
Always on. So let's say a defendant takes a plea deal at 8 a.m. In the old system, that's just a hole in the schedule. The judge, the staff, they're all just sitting there idle.
Wasted time.
But the RL model sees that resource gap instantly. It re-optimizes the rest of the day in real time. It might see a small civil motion scheduled for tomorrow, pull it forward, notify everyone automatically, and fill that idle time. It prevents the cascade by just consuming the gap.
And that idea of resource utilization, it's so clear when you look at travel time. The reward function is designed to just powerfully incentivize geographical efficiency.
It's not just about fewer miles.
No, it's about intelligent batching. For example, the system learns very quickly that assigning a judge to a series of cases in 3 neighboring courts on a Tuesday is, astronomically better than having them drive back and forth between opposite ends of the county over 2 days.
So it's just smarter clustering of work.
Exactly. And that drastically reduces travel hours, which means real cost savings, and it even reduces the carbon footprint from all that driving.
That's fascinating. And that same optimization, that extends to managing the judge backlogs, right? The models are trained to shrink that queue of pending cases. But the really sophisticated feature I read about is its ability to account for the different speeds at which different judges work.
Yes. This is so important for preventing burnout.
How does that work?
Well, the AI learns over time that, say, Judge A is just 20% faster at getting through complex commercial litigation motions than Judge B. So the algorithm can strategically give a slightly heavier load of those commercial cases to Judge A.
And balance Judge B's workload with other types of cases they might be quicker at?
Exactly. It's a huge game. You're not treating judges like identical cogs in a machine anymore. You're assigning a truly reasonable caseload to each person based on their actual work style. It's smarter and it's fair to them.
Okay, and what about that last challenge, the incredibly complex local rules? How does a machine learn all the little nuances of local court protocol?
That's the elegant part. It doesn't have to learn them in the way we think. The rules are just coded in as hard constraints.
So like a non-negotiable parameter.
Exactly. If a local rule says criminal cases must be scheduled before civil cases on Mondays, the agent gets a massive penalty if it ever violates that rule. It doesn't question it. It just finds the best possible path that works within that rule while also juggling everything else.
So it provides that flexibility without needing a human to constantly check a rule book.
Right.
Okay, so this all sounds incredibly promising,
Yeah.
but we have to be realistic. It can't be that simple. What are the challenges here?
There are definitely challenges. I mean, for one, you need large, high-quality data sets to train these models. If your historical data is messy or biased, the AI's policy is going to be flawed,
Garbage in, garbage out.
always.
Uh-huh.
Then there's the huge practical hurdle of integrating these new RL systems with the court's existing management software, which is often, decades old,
Ancient technology.
very rigid.
Yeah.
And finally, these models need to be constantly retrained. Laws change. Case types evolve. This is not a set-it-and-forget-it solution.
Right.
But if we connect this to the bigger picture, what we're really seeing is the transformation of one of the slowest, most bureaucratic parts of public service. As this technology gets better, courtroom scheduling will become far less dependent on one person's ability to juggle 1,000 things in their head.
It becomes a managed system, not just human effort.
Right. It becomes better equipped to handle the demands of modern society. The potential here is to completely revolutionize court operations by boosting efficiency, improving fairness, and just making the whole system more sustainable for everyone involved.
So what does this all mean? I mean, the integration of this kind of complex machine learning into a high-stakes process like the courts, it feels like a blueprint for optimization in other public sectors.
Yeah, absolutely is. Hospital operating rooms, air traffic control.
Anywhere resource allocation is complex and dynamic and, frankly, vital.
Mm-hmm.
Before we sign off, here's a thought for you to consider. Beyond just the raw efficiency, moving to a data-driven system that accounts for things like a judge's individual capacity. It fundamentally shifts resource allocation from a manual guess to a measurable, optimized process. So how might applying similar data-driven systems change how you view public resource management in your own community?
And to build on that thought, when we move these fundamental decisions into the hands of a complex algorithm, a system that's literally learning from its own rewards and penalties, we have to think about transparency. How much visibility do we, the public, need into the logic of these AI systems to maintain our trust, especially when the machinery of justice is being scheduled by a machine?